Good evening. We'll wait for a couple of minutes. Okay, you're able to hear me, Dr. Sundar? You're able to
Yes,
hear
sir.
me?
Yes, sir. Yes, sir.
Yeah, yeah. Uh, so we'll start. Dr. Shanti has also joined. So I'll just share my screen. Okay. The first thing I'm going to do is to now. Oh, sorry. Yeah. Okay. Before we go further on this, I'm going to explain it slowly, but let us digress that because we need some more knowledge. But before we do that, let me ask you how things have been, what are the issues, questions, and all that. Any questions? Yeah, no questions. I thought it's a tough topic. It's seen it. There'll be a lot of questions. So, uh, just to recapitulate what we did, of course, I have to, after today's class, I will go maybe deeper into MATLAB, slightly, through Chat GPT and without Chat GPT. Both of them we will do, but we have to know some amount of theory. The theory here is nothing, not big mathematics. We've been only looking at simple mass balance equations, and then what we call as PD, pharmacodynamic, which is actually the effect part. So if you look at these two equations is what we were looking at. Now we were here at this place. One of the things I did was slightly advanced. You can leave it on what is called delayed differential equation. So don't worry about it. I just wanted to state only one statement I'm going to make is that even if there is a delay in action, okay, to it is possible to account for it. That's all. One statement. Uh, the rest of it, you need not worry about it. Uh, it is possible to look at delayed action of the drug. Yes, that also a differential equation can be written. Okay, that is all to it. Now, so we have to solve these two things together. So we have come a long way. We have looked at so many things, and we're giving a bird's eye view of the mathematics involved. And what essentially we were doing is we were looking at how to formulate the problem. This is very important. How to formulate. So this we were looking uh, at the compartment models. Note this carefully that we are looking at what is that we are looking at? We are looking at mass balance. Okay, I said that formulating the problem is by three means. So you can have mass balance, which we did in each compartment. This is a big topic today. Actually, this mass balance, digital twin, everywhere it is being used. Uh, so that's the first thing. Then you can have momentum, conservation of momentum conservation, and then we can have energy. So these three lead to differential equations. There are other things as well. We will just stick to this now. So afterwards, what do we do? we go on to the next step. We solve the differential equation. And lastly, we interpret the equation. These are three. So fortunately for us, this we are not going to do it like an engineer to solving the differential equation. We are going to solve it using MATLAB or even write a code. Next week onwards, we will write codes on ChatGPT and then transfer it. So that is all we are going to do. We are only going to understand this part. It is very important. Okay. Now, there are number of simple things that we are going to have for mass balance, because Dr. Sundar is here. Uh, let's say that we have an artery. Okay, how now? How we are going to do it? So suppose there is an artery which is like this, you know, and that we are going to have. Let's say that A1, A2 are the areas. Okay, blood flow is like this. Okay, the question is, if the velocity, if A1 is equal to, say, um, it's the descending iota, say, what I can say about two squared into, so let's say that four, um, let's say four centimeters squared, let's say, and velocity is equal to, say, uh, 1 meters per second. Now, at this place, let's say that the area becomes, say, 2. The question is, what is the velocity here? Clear? The question is clear. Some number, I just gave some number. V is equal to 1. If area is equal to, at this place, area is equal to 2, what is V? Can someone, a simple example for, again, mass balance. Can someone answer this?
Hello.
Oh, yeah.
Uh,
Waiting.
I mean, if amount coming in should be equal to amount going out, right? So the flow,
Exactly.
the volume of the, yeah.
Yeah. You're right. Amount coming in should be equal to amount going out. So tell me the answer.
So area into velocity is equal to A1 V1 is equal to A2 V2.
That's all.
Okay.
Right? Because A1 into V1 is the volume flow per second. Right? So area multiplied by the velocity. Right? So that is the thing, but only thing is the unit should be the same. So I'll just say centimeters per second, just for. So units should be the same. Be careful with it. So in 1 centimeter per second, right? So volume. So in other words, 1 centimeter of fluid will be standing here in 1 second. For others to just understand. So 1 centimeter of fluid is standing here. So 1 second, that much fluid is going to enter. Area is equal to 4. So 4 into that area multiplied by this thickness is the volume. So that is equal to 1. So amount of fluid that is flowing in is 4 centimeters per second. And here, same thing, A2, V2. V2 is the velocity here. So A2, V2 is equal to 4. So V2 is equal to 4 by 2, that is 2. So obviously, when the area decreases, the velocity has to increase, because what is going in should come out. So this is called as very fancy name, continuity equation. Okay, is that clear? We'll stop for a minute. Just okay. Uh, Fine.
Yes, sir.
Yeah. So uh, this is an example. I'm going to go into more detail slightly later. But before that, we have to come back and learn some more things. Okay. Uh, Slightly is nothing. Today it's all taught in high schools. What I'm going to do. So this is from a branch called linear algebra. Don't worry about the name. Don't get. So we saw briefly this, yes, one or two concepts of it when I taught last time, when people are not there. Anyway, it's there in my the same. But anyway, I'm going to teach that again. Okay. Now, let us say that I have an x-axis and I have a y-axis. Okay. Now I'm going to draw a line. Right. So the line is one which connects 0, 0 to say 4. Here it is 2. So what is the coordinate of this point? 4, 2. Right? 4, 2. So this line takes you from 0, 0 to a coordinate which is 4, 2. Clear? So this line is, if you look at the length of the line, you can calculate the length of the line. Okay, there are two things to this. It has a length and it has a direction. Okay, so in high schools or even today in elementary schools, such a line, okay, with a magnitude and a direction is called as, anyone?
Vector.
A
Vector.
vector.
Okay, is called as a vector. It's a magnitude and the direction. Magnitude of this line, that is, magnitude means this length of this line. That's the length of the line. Okay, so how do I calculate the length of the line? Just this line. Magnitude is the length of the line. How do I calculate the length?
Pythagoras theorem.
Pardon?
Pythagoras theorem, applying Pythagoras.
Yes, Pythagoras theorem. Pythagoras theorem. So what is this length?
2.
2. What is this length?
4.
4. So what is this length here?
Root of 4 square plus 2 square. 16 plus
Root of 4 squared plus 2 squared. That's all. 16 plus 4 root, that is 20. Okay, so 2 root 5, something like that. So this is the magnitude. The direction is given by that angle, say theta. So one, is that clear? So this is the magnitude and direction. It is different from when I express temperature, 37 degrees centigrade. This is only one value. Okay, there is only one value called 37 degrees. That's all over. So this is called as a scalar. scalar. Okay, is that clear? Now, this is in 2 dimensions. What the vector? It can be in 3 dimensions. It can be 4 dimensions. What is 4 dimensions? Don't worry about it. It's very simple. We'll see it. Now, one way of expressing this vector, okay, is just have 2 entries, 4 and 2. This is what is called as a vector. Just 2 entries, 4 and 2. So any 2 entries like this in one below the other can be called as a vector. Okay, is called as a vector. So the vector, what we have got, can be extended to 3 dimensions. 4, 2, 3. I can have it 4, 2, 3, 5, and so on. Okay, so this is called as a column. I'm just writing it in a column. So it's a column vector. It's called as a column. Right. Now, let us write down a simple, what we know all along, a simultaneous equation. All of us have solved simultaneous equations in schools, right? We have solved, say, 2c minus d is equal to 1, and minus c plus d is equal to 0. Suppose I give an equation. So this is equation 1, equation 2. So I'm going to ask you to find what is c, what is d. Very simple. So what do? I multiply the second equation by 2 so that it becomes 2c plus 2d. Okay, then add them together. That goes off. Then d is equal to 1, or minus c, plus d is 2c minus 1. So 2d, d is equal to 1, right? Yeah. Then 2c is equal to, is that correct? What am I doing? Minus 1, sorry. So this is, I'm going to add these two, plus 1 plus d, 1. So c minus 2c minus 1 is equal to 1. C is equal to 1. This side you go, 2 by 2 is equal to 1. All right? Yes. So minus 2c. So 2c is 2, minus d is 1. Yeah. So we know this. Simple. But that's not my intention right now. I'm not going to do all this. But I'm going to take that equation and I'm going to rewrite it in a nice way. So 2c minus d is equal to 1, minus c plus 2d is equal to c. Okay. Now, there are two variables, c and d, which I have to find out. I'm going to put them here, c, d. Okay, I'm going to put it like this. And I'm going to introduce a very important concept called matrix. So I'm going to put here 2 minus 1 minus 1, 2. Okay. Now, I have rewritten this in a form and I'm going to introduce a rule now. So this is called, this whole thing is called as matrix. Unlike this, which has a column, a matrix, this matrix has a column and a row. So this is called as row, and 2 minus 1 is a column. So this matrix 2 minus 1 minus 1 2 has two rows, row 1, row 2, and this is R1, R2, and two columns, which is C1, C2. So it has two rows and two columns. Is that clear? First, I'm defining matrix. Is that clear?
Yes, sir.
One column is called as a vector. When I have more than one column, I call that as a matrix. Okay? So the matrix which I have now written, I'm going to put down some rules. Wait for a couple of minutes. Let's understand what's a matrix. Matrix has more than one column. Okay? So there are two columns. Two columns give rise to automatically two rows here in this case. So I say that it has two columns, two rows and two columns. So first I write the row, then the column. C, R. Okay, so it's a 2 by 2. This is here 2 by 2. This is multiplication is by. This is called by 2 by 2 matrix. So if I now going to introduce this 3, 4, 2, 6, 1, 7. So how many columns are there?
Two.
Two columns, right? Why doubt? Two columns. How many rows?
Three.
Three rows. R1, R2, R3. So how do I write this matrix?
3 by 2.
3 by 2. Yeah. So it is 3 by 2. In general, a matrix can be written as M. Sometimes people call this as M by N or M cross N or whatever it is. So in general, it is M by N. Now, why have I introduced this suddenly? We'll see it. First, let us understand this matrix. Now I know what's a vector. Vector is also a matrix which is, say, N by 1. N by 1. So this matrix, which is a column, can be called as 2 socks. 2 by 1. And this is 2 by 2. Okay. So let us now, why did I introduce? I'm going to introduce this as 2 minus 1 minus 1 2 C T. This is the left hand side. This side. Then I am going to introduce a rule called matrix multiplication. So what is matrix multiplication? So I'm going to now, why did I write it? Because you will see now when I introduce matrix multiplication. In this case, for this case, the matrix multiplication is I will go along the column, okay, multiplied by along the row. Let's see what it means. So I'm going to take this 2 multiplied by C plus take this multiplied this. So in other words, the rule is 2 multiplied by C plus minus 1 multiplied by D. Okay, so 2C minus D. Then I'm going to take this and then multiply by that. So minus 1 into C plus 2 into D. So this is minus C plus 2D. So look at that. This is nothing but the first equation. This is nothing but the second equation. So what is that essentially I have done? I introduced a matrix, okay, and then I rewrote the equation, the simultaneous equation, in a matrix form, along with a rule called matrix multiplication. Clear? Any questions? Yeah. Is the rule clear?
Yes, sir.
Okay. Now I'm going to do a few more problems because one by one we will go. I'm going to introduce. So I'm going to introduce three equations, and you have to write it in a matrix form. So let's say that x plus 3y plus 5z is equal to 4, x plus 2y minus 3z is equal to 5, 2x plus 5y plus 2z is equal to 8. Now, write this down in a matrix form. It's one help. First, let me put the vector x,
X, Y,
y,
Z.
z. So I
Z.
have to put a matrix at this place. And this
1,
vector, this is 4, 5, 8. That is this. Yeah. Now, tell me, how do I
1,
write this?
1,
1,
3, 5.
1, 3, 5. Then
1, 2
1.
minus 3.
Exactly.
2, 5 plus 2. 2, 5, 2.
Yeah. That's all. So what is that I'm going to do? How did I get this? Because 1 multiplied by x, 1 multiplied by x, then plus 3 multiplied by y, 3 multiplied by y, then plus 5 multiplied by z is equal to, this is a column, is equal to 4. I got the first equation. So I can get the second equation like that, third equation like that. Right?
Yes,
Is
sir.
that clear?
Yes.
Okay. Don't ask me to solve it because that can't be solved for very interesting case. So I'm not going to do that now. Just I'm only teaching you matrix. Okay. Now, what is the size of this matrix? This matrix?
3 by 3.
3
3 by
rows?
3. 3 by 3.
3 by 3. Okay. This is 3 by 1. Clear?
Yes, sir.
Now, look at that carefully. It's very interesting. This matrix actually operates on x, y, z to give me one vector. It operates on one vector to give me another vector. So it is a function. Say we said, remember, we said function x, function of x. So we said function of x is x squared, right? So function of x is x squared. Similarly, this matrix, let's call this whole thing here as a A. Okay, I'll put that like this. So A is a matrix. It operates on x. This is x. to give me, so let me call this as B, this whole thing as B, to give me, because if it's a vector, we usually put it in a flower bracket, give me B. So it is an operation. Let us say that, let's for a moment say that, forget B, I'm going to get B. Let me say that, let's say 1, 3, 5, 1, 2, minus 3, 2, 5, 2. Let's say that this is going to be 1, 1, 1. So this matrix A is going to operate on this X. So what is it? 1 into 1 plus 3 into 1 plus 5 into 1. So 5 plus 3 plus 8 plus 1, 9. So I get an answer. 1 into 1, 1, 2, 3, then minus 3, 0. Then 2 into 5, okay, 2 plus 5 plus 2, 9. So you can see that this is a function which operates on vector and then gives me another vector. Clear? So matrix is an, so actually this can be, this whole equation can be looked at as if there is a function called A, which I am extracting from this equation and then writing it as a function. So matrix is a, can be viewed as if it is a, function, but I still call this as a matrix. Clear?
Yes.
But any questions?
So X is all, so vector or matrix? Because if it's a vector, it should be curly brackets, right? For
So
X.
this is a curly bracket.
Before in the above equation where you would written A, X, and B.
Yeah, this one, no?
Yeah.
So this is, that's curly, okay.
Okay. Okay. I thought it was square.
Okay.
Yes, sir.
But doesn't matter. It's only a, I mean, so this thing. So now let us look at, so this is, so let me, so I can, just 3 equations I wrote. I can keep on writing a number of equations. So let us say that I write m equations. Okay, this is 3 equations. I'm going to write m equations. I have, how say, n vectors on which it is operating. Like it can be A, B, C, D, E, like that, n vectors. Okay, the vector size is n. That is, in other words, this is n into 1. Okay, there are m equations I'm writing. Now, it need not be n into n. We will see all that. We are not going to be worried about, just to write. So I have m equations and I have n variables, or which I want to find out. In general, in the previous classes, you have found out that m equations is actually m unknowns. M equations, m unknowns. So 3 equations, 3 unknowns. 4 equations, 4 unknowns. Let's just change it a bit, just to illustrate what is matrix. So what should be the, how do I write the size of this matrix A now? So there are like this. How many are there?
M number of rows.
So how do I, what should be the size of A? How many columns?
Columns.
See, look at this. This is going to multiply with this first entry. This is going to multiply with the second entry. This is going to multiply with the third entry. So this is going to multiply with the fourth entry. So how many?
N.
N. So
M
what
by
is
N.
the size of this? M by
M
N.
by N.
Um,
Okay, look at this. Interesting. So what is that I'm going to get from here? What is that I'm going to get here?
N by 1.
Mn.
N. So here, I mean, anyway, I've written this as M. Let me have it M itself. M by, so that I don't confuse you. So let's say that M by M. Let's say M by 1. I'm not, I mean, I should have changed it, but doesn't matter. So M by N. This is M by M, M by 1. So how much should this entry be?
M.
Yeah. Okay. Fine. So this number of columns should be equal to the number of entries in the vector. Number of columns should be equal to the number of entries in the vector. So in other words, this should be equal to this. Then only I can multiply it correctly. So let us see, let's take something else. Let's say that there is an entry here, here, here. This is the first row. Second row. Entry here, here. So let me, instead of putting entry like that, let me write it. 1, 2, 3, 2, 3, 1, 3, 4, 6, 6, 5, 1. Seven, 8, 2. Okay. Now, so what is the size of this?
5 by 3.
Well, how do I write this?
5
5
by
by
3.
3.
5 by 3. Right? So how many entries should be here?
5.
5.
3.
Oh,
Oh, 3.
3.
3, 3, 3. Yeah.
So let us say 2, 6, 3. Okay. This is how I'm going to multiply. So how many here? How many I'm going to get? Right hand side. I'm going to multiply this.
3. 3.
3.
3. Oh. So I'm going to multiply this by this by this by this, and add. So I get one entry. Right? Right? Then so then I'm going to multiply this by this, plus this by this, plus this by this. I'll get another entry. Then I'm going to multiply this by this. Every row I'm going to multiply. Then this by this by this, add. I get another entry. So how many entries I'll have?
5.
5.
5 by 1. So clear? So there is 5 entries. So in general, if I say, I'm going to put this rule of multiplication in a minute. M by N. Okay. N by 1. And I will get M by 1. That's the rule. Look at that carefully. This and this ultimately gives me M by 1. Any questions? Look at that and then let me know. I will repeat if there's any questions. So this is the same matrix. This is A matrix. And that is my X. And this is a B. So I write A M by N, X N by 1, P M by 1. So I'm only teaching you nothing, rules, that's all. There's no big mathematics in it. I'm only teaching rules. What I'm introducing some terminologies. They are they are so important. Unfortunately, uh, many doctors don't realize. Say, for example, we all of us talk about AIML, we talk about imaging, we talk about all those things. Okay, everywhere this is what is used. Suppose suppose you have an image. All of you work with images. Say let's say X-ray image. Okay, so in this X-ray image, you actually you will have some resolution. Okay, 1650 by 840 or something like that. You will see this is the resolution. What does this mean? Every X-ray image, or you take ultrasound or take MRI or whatever it is, you have something like this. It's called resolution. Okay, so what's the difference between 1.5 Tesla to 3 Tesla? You will have different resolutions. Okay, so in other words, there are so many pixels in which information is stored. Okay, so 1650 is the number of rows and 840 is the number of columns. Okay, and that may vary. So actually, what usually you do is, in this case, when you want to uh, do any analysis further, you will just stretch it out and write it as a big vector, 1650 into 840 vector. So one here goes here, this goes here, this goes here, and keep on going down. So you can convert it into a vector. This is how, for example, tomorrow you want to do AIML. This is how the intensity at each point is looked at. So you will just expand it as a vector. Okay. So you've used this already. Any manipulations that is done maybe in this vector. Okay. So coming back to this. So m by n by 1, m by 1. So this is A operates on a vector to give you another vector. Can I not state like that? Operating on means like x function x equal to x squared. So this function called square function operates on x to give me x squared. So operates on. Is the term. It operates on. It applies itself on. That's it. Okay? Is that clear? Operates on. Now, you remember that we had two functions, okay, cascading functions. Okay, t became x, x became y. So here the first case is x is equal to function t. The second case y is equal to g of x. So that I can now write y is equal to g of f of t. Right? We did this. So we also saw that this can be written as g f of x. Oh, sorry, tt. right? I'm cascading the functions, two functions. So for example, I can say x is equal to t squared, okay, y is equal to x squared, then y is equal to what? I have to substitute here from here to here. So it becomes y is equal to t power
4.
4. Like that, I can have two matrices. Matrix A and matrix B. I'll give you slightly more examples as we go on. Matrix A and matrix B. Okay. First, a small theory and then example. Now, I can have two matrices, A and B. Now, these two, this is one function, this is another function. So let us say that it operates on X, vector X. So look at this. So B, let's say vector T. Let me call the same name so that you will not get so let's say that this is a vector T. This is a matrix F, and this is matrix G. Now, F is operating on T, right? The first. What will that give me? Another vector. Clear? Is that clear?
Yes.
Yes.
Then that can operate on G. I will get a vector Y. So this is a cascading function. Like the function, this is multiplication. This is multiplication. I'll give the rule in a minute. I can also have here f of t is equal to g of t plus some k of t. Addition. Similarly, I can have here also g plus f acting on t to give me, say, y. Possible. So I can addition. I'll define the rules in a minute. So I can manipulate matrices, okay, add it. Only thing is I can't divide it. Like we can't divide the function, we can't divide it. We are going to put a new rule. Okay. So why am I doing this? See, for example, Dr. Sundar is asking a question, where am I going to use it? Good question. So we'll see where we are going to. Dr. Sundar treats a number of patients. Let us say that in a month, he treats about, sir, can I say 500 patients he's going to treat, right? Let's say in a month, about 500 patients he's seeing. Now, he wants to store the data of the patients. Okay, so he wants to store the BP, fasting sugar, PP, all those kind of things. He wants to store it. Now, how will he store it? He can store it in a matrix form. So, patient 1, BP, so let's say systole, diastole, BP, diastole, then you can say fasting sugar, PP, whatever, HDL, blah, blah, blah. So the first patient, he can enter values. You can say 140, 90, 90, and so on. Right. So then patient 2, patient 3, patient 4, okay, patient 500. Let's say that there are some 10 values he is entering. Okay. So what has he done essentially? He has put his patients in a matrix form. This is what you do in Excel also. But anyway, this is a matrix form. So what will be the size of this matrix?
500 by 10.
500 by, sorry. 500 by 10. So you can express it in a matrix form. You'll see what are the manipulations you can do with this matrix later. Just, I want to tell you that it can be a matrix form. Okay? Now, this matrix is a tall matrix. Why is this called tall matrix? Because 500 when compared to 10. Right? Now, Dr. Sundar has, so he has looked at the patients for a long time. So he has some interesting observations to make. So he feels that systolic blood pressure is, he ranks them, say for example. Okay. And he can give a weightage to each one of them. So for example, he can have a risk score for them. So he may say that, look, I want to develop a risk score for each one of them. Let's say that he gives a weight. So the weight for systolic blood pressure is 0.2. Diastolic blood pressure is 0.3. Fasting sugar, let's say 0.1. Postprandial is 0.4. Something like that. He can give some kind of a weightage. Okay, this is common. So he wants to know, this is the risk factor. He wants to know, okay, if these risk factors are combined, what will be the risk for my patient, patient one? Okay, this is what all the, AIML, everything is going to be doing. So then how does he find out the risk factor now for the patient? So how many entries will be there in this risk, in this weightage?
10.
10. Right? So this is 10 by 1. So what will you get on the right hand side?
500 by 1.
500.
500 by 1. So this is actually the risk for each patient. So he will say, okay, 140, I'm going to multiply by this. This, I'm going to multiply by this. This, I'm going to multiply by this. And so on. And I get one number at this place for the first patient. So second patient, 200, 120, bad patient. Then he will multiply this by this by this, then all those things by this, and he'll get second score. Right? So he has actually used a matrix multiplication with a weightage to get a risk factor. So he has actually used the concept of a matrix. So what is that we have done? It's a simple thing which you know, but now I've expressed it beautifully in a mathematical structure called matrix. Is that clear? Arjun is there? Hello?
Yes, sir. Yes, sir. Hello.
Yeah.
Hello.
Arjun?
Yes, sir.
Yeah. How is it clear?
Yes, sir.
So this is what is this matrix multiplication. I can add them also, as I said. These are operations of the matrix. Clear?
Yes, sir.
Yes, sir.
Okay. So this actually this has a lot of whatever it is, it has a whatever is there, it has a practical implications. Okay. Should I multiply like this? No need. Our good old MATLAB will do all these operations. All these operations. So let us uh, let's do a simple problem, or this our simultaneous equation. Okay. So let's look at the simultaneous equation. So simultaneous equation can be written as A. Now I'm going to be slightly abstract. Is equal to B, right? A is a matrix. Say, let's say M into N. X is N into 1. Okay. This is, so no, I'm not going to do this because this is difficult. So I'm going to say M into M, M into 1, M into 2. Now, let's go back to this. Actually, what is that I'm going to do here in this? This expression. What am I going to do here? I'm trying to find out. What is that I'm going to find out? X, Y, Z. This is what I do in a simultaneous equation, right? This is what we did here. Look at this. So what did we do? This is the equation. I tried to find out C and D, right? This is what we did. And ultimately we got what is C and what is D. Yeah. This is what we did. Clear. So what I do is, in general, if I were to generally express it, what is this vector X? This is a question I'm going to ask. Clear? So I have some numbers here. I have X, Y, Z here and some numbers here. So what is this X, Y, Z? I've just briefly written as X here itself. Actually, this is X, Y, Z. If you're slightly confused by why are you writing only one, so just out of laziness, if you want, I can write it as X, Y, Z. Y, Z. That's what. So your question is, what is X, Y, Z? I'm giving an equation. Is the question clear? That's what is the question.
Yes.
Okay.
Yes.
Now, look at this equation. So I'm writing that X, Y, Z as X is equal to B. Now, if this had to be like AX is equal to B, so what is X? What will you say?
B by A.
B by A. But in matrix, there is no division. Instead of that, we will write it as inverse. So I'm going to introduce a third thing. I'll come back to this. I'll introduce terms and then I'll come back to each operations, maybe by next class. So if I write AX is equal to B, I can multiply this by what is called as A inverse. I'm introducing what is called as A inverse. A inverse is something like 1 by A. Something like it's not nothing to do with that. B. Now, what is A into 1 by A?
1.
1. So A inverse into A is what is called as that 1 is identity, and that is like in the diagonal. This is called as the diagonal terms. That is the this won't have a diagonal term, but I mean, because it's so these are the diagonal terms. So diagonal terms of 1 is called as the unit matrix. Like we have unity here. When I multiply A inverse A, then I get a unit matrix with that. Clear?
So unit matrix and identity matrix are the same terms for
Yeah,
synonyms.
unit or identity matrix. Yeah. Okay. Because it's
Yes.
just another word for one. That's all. Clear? So
Yes, sir.
I can now put down. I have now put down the rules for this thing. But inverse, I'm not going to tell you how to calculate because my good old MATLAB will calculate all that. Right? So I can do all those things. I will do a lot of this material operation in the next class, but I want you to assimilate what they are, and I'm going to because once I do it in the next class, it is like going through the whole thing again. Right? So suppose let's look at this. Let us look at this figure. So I introduced a vector 4,2 here. So actually, you can also look at that and say that this is 2-dimensional. So I'm giving a dimension to the vector. I'm giving a dimension to the vector. So similarly, I can give a dimension to the vectors here as well, to that vector I gave. So if I now say this vector is m into 1, so this vector, that vector which we saw sometime back, sits in 2-dimensional space. So what is the dimension of this vector right now? We will modify it later because there are other things for it. So modify it later. But can I not call m as a dimension? Okay. So there is a dimension involved in the vector. So let's say that 1, 0, 0, 0. Okay. So where is this vector sitting? This vector is sitting in
1 dimension.
how 1 dimension?
There's only one column. Oh,
No, 1 column, but entry. Here also there was 1 column,
4 entries. Okay.
2 dimensions. So here sitting in 4 dimension.
Mm.
Clear? 4 dimension. Any questions? Am I clear?
It's the number
Don't
of
imagine.
entries.
Number of entries, that's all.
Okay.
Right now we are looking at number of entries. Number of entries. Any questions so far? I know there's a lot of concepts. I'm going to maybe I'll stop at 8:15 so that I don't overload. I don't want to overload. So there are other interesting things.
Can you give an example for that A-1 matrix? So, can you write it as an example? Like
A inverse.
How the A inverse would look like if you are given a
It
matrix?
will look exactly like the same way.
Can
Okay.
that the equation can be solved with an example, sir?
Yeah, that is what we are going to solve using MATLAB. Next class, we will solve many problems like this. Okay. Given a, so in other words, your question is given
Yeah.
an A, something
how
like
the A minus
like
1
this.
look like?
How do you get A inverse? It's called A inverse. How do I
Yes.
get A inverse?
Yeah.
In A, INV A, that's all over. A command in MATLAB. That's all. So we will see how we have to how to write a matrix. That's the first thing we will see, and then we will see how we are going to solve this. Uh, I would say equations or inverse and so on. Okay, so there are, in fact, MATLAB is nothing but matrix laboratory. Okay, it is called as matrix laboratory. That's why it is very simple. Nothing. So suppose I want to enter a matrix, say 7. Sorry, so 7, 10, 5, 3. I'll have to go to MATLAB, but it's going to take time. That's why I'll do it in one class completely. So suppose I'm going to do this. Okay, so let's say matrix. This is the matrix. Then the command is just mat is equal to 7, 10. Then I'll put a semicolon here. Okay, and that's the first row. 5, 3. So that would give me a matrix which is 7, 10, 5, and 3. And there are ways in which I have to introduce a lot of things, only simple commands. So I will do that the next class. I can do, say, addition. I can do subtraction. I can find out inverse and so on. Okay. So now, so let's say I one thing and open this up. I'll come out of this. I'll enter into MATLAB so that what Dr. Sundar asked will be clear. Okay, I'll come out of this. Okay, right? Give me a second. I have to enter into this thing. I'll get out of this thing. Oh, sorry. Are you able to hear me? Hello?
Yes, sir.
I think my mic is setting is, I'll just, yeah, both of them are correct. Can someone speak, please?
Able to hear, sir.
You're able to hear? Okay. For me, it's bit. So let us. So let's look at a simple matrix. Matrix 1, 3, 2, 4. Okay. Now I'll use this because it's just a command. So I'm not going to write a program. I'm going to use directly the console. 1, 3, as I told you before, 2, 4. Okay. Now let's execute just this. So this is the matrix. Okay. 1, 3, 2, 4. Simple matrix. Now, Dr. Sundar wanted to invert it. So I'm just say invert A. Oh, sorry. Invert A. I'm going to invert it. So that is the inverted matrix. A invert A is what? A inverse. Inverse of A. A inverse. Is that clear, Dr. Sundar? This is how it will appear. How do I know it is correct or not correct?
Yes, sir.
So I have to multiply A and inverse of A. When I multiply both of them, what will I get? Unit matrix. Right?
Yes.
So I'll say A star, that's a multiplication, inverse of A. So what does that give? 1001. Is it clear? Hello?
Yes,
Yes,
sir.
sir. Yes, sir. Diagonal, it is 1, 1. Yeah.
Yeah, I know why the voice I'm getting is very feeble. Output volume is very high. Okay, just a second. Let me wear my. Yeah, is it clear?
Yes, sir.
Yes.
Okay. Do you all of you have MATLAB opened or something? So let's do one thing. Let us solve a problem. Okay, simple problem. Let us say that I'm going to define A first. A. 3, 4, 1. The first row, minus 2, 0, 3. Second row, 1, 2, 4. Third row. Now, let's say what this is. So that's the matrix, A matrix. So remember what we wrote, AX is equal to B. Now I have to find out X. So I should know B. Let us say, let me define B matrix, a B vector. So this is say 2, 1, 0, 2, 1, this thing. So I have to make it into a column, not a row. So I will say that B is equal to, I'm going to just change it a bit, 2, 1, 0, and then put that as a column. So this now that this is called transpose. I'll explain it later. So just that I have made it into a column. I'll explain it maybe in the next class. So that makes it a column. So actually, I know A. Okay, I know B. I have to find out X. So what is X? Remember, X is equal to A inverse B. So X is equal to inverse of A multiplied by B. That's all. So that is X. That is X. Okay. So actually, inverse is a very difficult thing even for MATLAB. So there are other methods. This is to just show you. Yeah. So let us define another matrix, which is say B, just to show you what, let's say 1, 2, 1, 2, let's say 3, 1, 4, 4, 3, 6. Oh, so 4, 3, 6. So that is, let us say C is equal to A plus B. Now, you can see what it has done. So our original matrix, so A, 3, first entry is 3, first entry here is 3, first entry is 1. So C now becomes, so every entry is now added. That is what is called C is equal to A plus B. Clear? So it's very simple. Suppose I want to multiply, I just say C equal to A, B. So I got the multiplication, one line, that's all. Nothing I need to know. So I can similarly, I can say C is equal to A minus B. That's all. So these are the operations in simple operations on matrices. As I said, matrix is something like a function. So any questions? So there are other ways of doing it, the solving it. I'm not going to do it now. We'll do that later. Okay. I'm going to come out of this. I'll go back to my iPad. Yeah, you're able to hear me?
Yes, sir.
Yeah. So we've seen a number of concepts in matrices, a number of things. Okay, they have matrix, all the operations actually form the basis for all your data analysis. Everything is the first. There are two things. One is matrix, which comes under what is called linear algebra. Okay. The other one is, of course, probability. So I'm going to do a few more things in the matrix form, and so I'm going to give you one problem which you try it out in now that I just showed you in MATLAB. So 3x plus 2y plus z is equal to 1, x2 is equal to 2, sorry, not x2, y is equal to 2, x plus 2y is equal to 3. Okay, this is the three equations. Write it down and then find out what is x, y, z. What are the values? Use MATLAB to find out what are the values of x, y, and z. X2 is already, x, y, z. Y is already 2. So you can, that is not a problem. You can find out x1, x and z. Right? Okay. What's the time? Yeah. I think we'll stop here. We've done a lot of things. I want you to go into these details. We will do more of this before we go back again. I'm going to marry this with what we were doing before. I will do that in the next class. I want you to see whatever we have done, and if there are any questions, I would love to answer. Are there any questions? We will see more geometry of understanding the geometry in the next class. Okay.
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 How's it? Shanti is there, I think.
I'm here.
Yeah.
Yeah,
Clear? Any questions?
no, it's clear.
Yeah, you can. I would suggest that you look at this once, and we will discuss this again. I'm going to say I'm not going to be restricted with 24th April. We are going to stop this thing. I'm not going to be restricted on that. I'm going to continue till I get, some understanding, because this is a key thing where whatever thesis you're doing, some maths you will use it. Then then we will do a few problems to consolidate whatever we do. So there will be some assignment and all. So we'll have assignments and we'll have one final test at the end. Okay. So we'll stop here and we'll continue in the next class. Dr. Sundar, you want it on Thursday because you said you need a couple of days to go through it.
Any day, sir. Actually, let others also opinion about that, about their convenient times. So
I understand what you're saying. Say, if I'm not traveling, I have no issues on doing it on Thursday.
yes, sir. If others are okay with Thursday, also okay, sir. Otherwise, I'll be happy to be in Wednesday also. No problem.
I have a request for
Yes.
just this week only. If it could be Wednesday, because Thursday, because this weekend is Easter, so I was planning to go home. So
Okay. Oh, okay.
only if it's that.
No. I fully understand. Okay, so we will have it on Wednesday. Wednesday, you are here, Joseph?
Yes, sir.
So we will have it on Wednesday.
Okay.
No problem.
Okay.
No issue. Okay. Good. Great. Okay.
Okay, sir.
Okay, sir.
Yeah. Thanks.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir. Thank you, sir.